All right, welcome to this part 3 of simplifying square roots or radicals using a factor tree. So without using a calculator, simplify the square roots using a factor tree. And let's just go ahead and get started right out the gate here. We have a square root of 98. Okay, square root, and again, this is the only one of the radicals that does not put a 2. It's square root. You're supposed to just assume that you need to find two perfect pairs, right? So now the next step in finding two perfect pairs is breaking down that 98 into all of its smallest multiples. So 98, I know, is 2 times 49. And I know 49 breaks down into 7 times 7. So 98 is 2 times 7 times 7. These are the smallest numbers that will multiply to 98. And I'm just going to substitute these numbers, 2 times 7 times 7, for the 98 inside the radical. Moving forward, I need to find two perfect pairs. I have two sevens. I can pull out one value here. Hey, remember there's an invisible one unless there's another term here. X, Y, Z, 5, 25, whatever. There's that invisible one. Show the invisible one. It'll help clarify. So two perfect terms to pull out one. I got 7 times 1. That 2 is a loner. It's going to stay inside that radical. And you can see here, I'm showing you further these steps. 7 times 1 is 7 times the square root of 2. Now, if I'm going too fast again, please go ahead and rewind the video. I would like to go over a little more of a complex topic. It has to do with solving radicals with fractions using, of course, a factor tree. So let's go ahead and simplify the square roots. We have a square root problem of 25 divided by 100. Remember, every fraction is a division problem, and that is a square root. You can write that 2 up there. It's like an invisible 1. Go ahead and show it. That'll help clarify what you need to do. So we're going to use the quotient rule in order to kind of break down this radical or square root. But first thing we're going to need to do is find out all of the factors of 25 and 100. So breaking it down using that factor tree, I have 25 is 5 times 5. So I can substitute 5 times 5 into the radical here. I have 100. I'm going to break that down using the radical tree. The factor tree. So I can substitute into the radical. 100 is 2 times 50. 50 can be broken down a little bit further to 25. And I know 25 is 5 times 5. So you can create, once you know the values, 25 again is 5 times 5. You can substitute for that 25, 5 times 5. 100 is 2 times 2 times 5 times 5. You can substitute those values into 100. And what I'd also like to show you is you can see here, because this is a fraction, right? The quotient rule says you can take this radical and place it over the numerator, which is the top part of the fraction, and also the bottom part of the fraction, which is what I've done here. I've taken a square root of 25 on the top, simplified it to its factors, 5 times 5. I took a square root of 100, placed it on the bottom of the fraction, the denominators, and placed in its factors 2 times 2 times 5 times 5. And so absolutely you can do that when you have a fraction that is inside the square root. Now just follow the rules that we have gone over together. You need two perfect pairs to pull out one value. You want to multiply it times the 1 out there or whatever term is showing. We have two perfect pairs in the denominator radical, 2 times 2. So you pull out 1, 2. You have 2 5s. You pull out 1 5. I'm going to show you here in these next steps how you can simplify a little bit further. Again, you have pulled out, you got 2 terms, you pulled out 1. So 5 times 1, pulling out 1 term of 5, 5 times 1 is 5. There's nothing left in the radical. That radical disappears, right? Square root of 0 is 0. You have 1, 2 you pulled out here. You have 1, 5 you pulled out here. Again, you need 2 perfect pairs to pull out one value. 2 times 5 times 1 is 10, right? Square root of 0 is 0. So that radical is gone. Now you're not quite finished with this particular problem. You need to simplify a little bit further. 5 divided by 10, or 5/10 as a fraction, is not in simplest form. So you're going to have to find a number you can divide into top and bottom evenly without a remainder. And I'm going to show you that here in the next steps. I can divide 5 into both top and bottom evenly without a remainder. 5 divided by 5 is 1, because I know 5 times 1 is 5. And again, 10 divided by 5 is 2, because 5 times 2 is 10. And so we have simplified that radical. Hey, math is easy. Take it step by step. Thank you for joining me.